Hello everyone and welcome to this session of Autonomous Vehicles Online brought to you by Automotive IQ. If you've just found us, welcome. My name's Tom Phillips and I'm the editor of the Automotive IQ website. Thank you very much for your time today. In this session, we're going to learn about how to develop critical ADAS infrastructure systems from one of our event sponsors, Parasoft. Now, this session is unique in this event as we have two presenters, Mark Lambert, who is the Vice President of Products at Parasoft, and he's going to be joined by Jason Stinson, who is the Chief Technology Officer at Renovo, one of Parasoft's clients. So if this is one of your first sessions, here's a quick recap of how the system works. During the webinar, if you have any questions for Mark or Jason, please pop them into the Q&A box and we'll get to them at the Q&A session at the end of the presentation. Also, if you have any technological problems, I'll do my best to sort those out and get on them straight away. Pop them in the box too. All those widgets around the screen can be resized and dragged around, so please make sure you're sitting comfortably, and I'll hand it all over to Mark and Jason so we can begin.
Great. Thank you very much, Tom. Thank you for the introduction. Thank you, everybody, for joining today. As Tom mentioned, my name is Mark Lambert. I'm the Vice President of Products at Parasoft, and I'm very excited to have Jason Stinson from Renovo on the call here with us today, where he can talk about what Renovo is doing around automotive edge computing and talk about their data platform, which is really exciting and innovative in today's automotive space. A little bit about Parasoft first. Some of you may be aware, Parasoft has been around for a little over 30 years. We do like to say we're one of the best kept secrets in automotive safety. We have actually been focused on safe and critical development systems for well over 2 decades now, bringing a whole suite of technologies to market that helps organizations streamline compliance with ISO 26262. We also do work across other safety critical markets as well as medical devices, industrial automation, functional safety, etc. About the suite of technologies today, and I'll talk about how it applies to ISO 26262. I will be talking about static code analysis, where we're actually members of the Measure C and Measure C++ working groups. So touch upon some of our partnerships and relationships that we have with integrations with chip vendors and what have you. Now, with that being said, I'm going to hand over to Jason and let Jason talk about Renovo and the great work they're doing. Jason.
Thanks, Mark. I appreciate it. Again, thank you to the Automotive IQ folks for facilitating this, and also very much thank you to our partners, Parasoft and Mark, for inviting us in today. So a little bit about Renovo, for those of you that don't know, we build an edge-centric data platform, data management platform. So primarily what our company does is help our customers to develop and deploy ADAS or advanced driver assistance systems at scale by helping them to manage all of their data. We provide a turnkey solution that helps to accelerate the development cycles, helps to push through the validation cycles, goes all the way into production, and ultimately reduces operational costs. So that's what we do. We're going to be talking a little bit about today the platform itself and how it works, and then talk about what some of the requirements are of data in today's automotive industry. So I think it's back to you, Mark. Nope, actually, I think that's back to me. Sorry.
Yeah, sorry, Jason. Trying to get these windows to move out of the way. Okay, so yeah, it's actually to you.
No problem. All right, so let's dive right in to the automotive data platform itself. So we like to think about it as 5 key elements of the data platform. So I mentioned already that it's edge-centric. What that means is we think of the vehicle itself as part of the edge compute, as well as actual edge-based devices that are either co-located on premises or relatively close to your development facilities. It's intelligent, so when we bring the data in, we're not just doing file management, we're actually managing at the channel level, at the metrics level, or the object level, and we can filter that data, we can index that data, we can enrich that data. It's very scalable, so it's built on a clustered architecture, which means we can scale from your small development fleets of 400 or 500 vehicles all the way up to tens of thousands or even hundreds of thousands of production vehicles. It's an open system, which means the framework and the API are open, and we support a lot of third-party providers into the ecosystem. We definitely can't do it all, and so we highly encourage and invite ecosystem partners on the platform itself. And finally, as I mentioned, we consider the edge not just an appliance sitting next to the vehicle. We consider the vehicle itself part of that edge compute, which means the software has to be able to coexist and live on the vehicle with other safety critical applications, which means the platform has a full safety model. It's fault tolerant, it's reliable. It has to apply to all the standards that are required to go into a vehicle. Let me switch to the next slide. So diving one level deeper. So the way at Renovo we think about data, this is kind of our view of the automotive world. We think about it in a big data loop. So we have our creators that are generating or creating the data. We need to store that data in some sort of a database, and then ultimately deliver that data to a number of different services, including back into more creation phases. So just to give you a little bit, maybe unravel that loop a little bit and talk to that some more. So in the creation phase, you have things like sensors, your camera, LiDAR, ultrasonics, as well as traditional CAN bus metrics or flex ray metrics type numeric values like throttle position, pedal brake position, RPM. We also have monitors at this stage, which are monitoring your things like your compute resources, your networking, basically just monitoring the health of the overall vehicle. And finally, different applications, the actual things that are doing work within the vehicle itself. All of these are generating massive amounts of data. Depending on the type of vehicle you're running, in your development fleets, you're most likely generating, if you're developing ADAS features, you're most likely generating on the order of 1 to 4 terabytes of data per day within the vehicle. That's what's being generated. And you somehow need to be able to get that data, index it, understand it, and get it off the vehicle. And so you're generating them in the creation stage. In the storage phase, we're able to store into a number of different types of databases. One is a metric store, which is primarily structured data, mostly numerics, although some string data, but it's generally characterized by being structured data. We have blob storage, which are large data, like camera frames or LiDAR point clouds. Often it's structured, but often it's unstructured, things like JSON objects or metadata. And finally, we have a sample store. A lot of people also call this a resynchronization store, where we actually synchronize all this data and get everything to line up. And finally, we have the deliver phase where we are taking the data from this database and pushing it out to various places. One is, of course, transporting off the vehicle, getting it somewhere else. Be able to access the vehicle, query the information that's in there, to visualize it, or to potentially feed it back into the creation phase. And finally, be able to manage the data, manage what's in the database on the vehicle, the database in the core edge node, as well as in the cloud. So let's go to the next slide. So this is, again, looking at this even a slightly lower level. And the on vehicle, which is on the left-hand side of your frame, we have the things that are creating the data are things like, a CAN bus publisher, or a FlexRay publisher. We also have camera publishers, LiDAR publishers in these ADAS vehicles. All of that data is then being stored into these databases on the vehicle itself. So in the case of CAN and Flex, as well as some of the data from the cameras and the LiDARs, we're putting that data into a metric storage database. The cameras and the LiDAR are also generating very large frames or point clouds, so those are going to the blob store. We have services then that are able to transport that data off the vehicle. We have receivers for that data off the vehicle. The off the vehicle could be the cloud. It could be an edge-based core computing device next to the vehicle. It's receiving that data, does an acknowledgement back to the vehicle, as well as stores the data into similar databases off the vehicle, as well as being able to generate the sample store. And then finally, you can then pull that data out to visualize it, query it, manage it. One thing of note is this entire architecture is a microservices architecture, which means each of these boxes is its own individual application, which means they can be multiple instantiations. You can transport data not just off the vehicle, you could transport it to removable drives as backup. We can instantiate multiple metric store if you want to split the data. You can do your visualization on the vehicle. You can do your visualization off the vehicle. All of these are a modern microservices architecture, which allows you to basically multiply instantiate and scale this up and reconfigure it in any way that you need. So having said all that, that's how our system works at a very high level, a simplified level. Why is data important? So we look at this as 4 primary categories. So the first one is hopefully fairly obvious to the audience for feature development. So we have all of our engineers, all the OEMs have their engineers running around. They're trying to develop new ADAS features, whether it's lane keeping or adaptive cruise control, or they're trying to improve these systems. In order to build and improve those systems, it requires test cases and scenario building. So data is vitally critical for being able to find that object that wasn't able to be classified by the vehicle. And so getting those camera frames off the vehicle, identifying which ones they are, and being able to understand them is super important. On the validation side, so this is obviously the next step, being able to ensure functional behavior, and maybe a little bit even more important, being able to verify adherence and compliance to your requirements and or standards. So this requires data to document. It requires data. So that data is vitally important to basically being able to get the vehicle out onto the road and into customer hands. The third area is something that we've seen increasingly over the last few years is the liability side. So we're getting to the point now in the industry with the kind of data that's being generated that we can actually rebuild a scenario, an aberrant event, almost down to the microsecond level. We've seen that in a number of pretty high-profile cases that we're able to actually understand exactly what happened in a specific corner case, and whether it was something that the software didn't anticipate, whether it was something that the user didn't use in the right way. We're able to build those scenarios and actually vastly improve the way that we think about corner cases and aberrant situations. And the last area is something that the automotive industry is really just starting to understand, or maybe it understands it well, but we haven't quite built these models to a large extent. But the vehicles and the vehicles that we're building in the industry have a pretty unique position in terms of the information that they gather about the behavior of both the vehicle and the consumers. That data is extremely valuable to a lot of different industries, whether they're municipalities or commercial entities. This information is very valuable, and it's going to change the way that we think about things, change our lives, and ultimately also build a lot of really interesting business models and revenue opportunities. So hopefully that's fairly obvious to everyone. What does that mean in terms of developing data platforms? As I mentioned on that previous slide, this data is becoming ever more critical to the automotive industry. This means that it isn't like the data systems of the past, whether those were simple telemetry systems or what you see on an OBD bus or your infotainment contact list. These are vital. This is vitally important information both for your developers as well as your legal teams, as well as your business teams. And it requires that we have a higher level of quality, a higher level of reliability, and a higher level of security. We often use the example of the black box or the flight recorders that are in the airline industry, the aerospace industry. We are getting to the point with the data systems where it is that important that that we basically build hardened systems that are safe and reliable and secure. It requires an ISO 262-like approach. You can see down in the lower right-hand corner, I've shown the traditional ASIL chart. The ASIL chart itself is geared around safety systems. It's geared around being able to judge safety systems and be able to grade them. We see the similar sort of concept being applied to data itself, that understanding what kinds of data you're capturing, how important is it, and that will drive the software requirements for the platform. We're really excited to have Parasoft as a partner. Their tools are very critical to Renovo to being able to develop these platforms in a way that is safe, reliable, and have high quality. We're able to validate relatively early in the development phase, so we're not bolting on safety and reliability at the end of the cycle. We're able to build it in throughout the entire development cycle. The dashboards and the traceability that are provided by their tools are amazing. It helps us to basically narrow in relatively quickly without having to kind of search around and figure out what is this static analysis tool trying to tell me about what's happening. And it's super valuable to me as a manager to understand how the team is doing and anticipate what's coming down the road. So that's about all I have for today. I'm happy to hand it back to Mark.
Great, thank you, Jason, and thanks for that great overview as well. And I think one of the key elements there is making sure that you're building a system that complies to the regulatory compliance of ISO 26262, because there's a certain level of trust that needs to be within the tool chain, within the supply chain of the automotive platforms today. Now, obviously, what we're talking about from the point of view of Renovo right now, where you left off there, is the application of code analysis during the early stages of the development process. And really, this is the first step, leveraging industry standards, which can help us identify reliability and security issues that are hidden within the code base. The second version of ISO 26262 in 2018 added the concept of cybersecurity and cyber systems to the standard, and really represented a significant movement forward and acceptance within the industry that these systems are getting more and more complex. So traditionally, MISRA was very, very prevalent within the industry as the standard of choice, especially around C programming languages. However, ADAS really kind of stepped up the game as the C+ language evolved. The MISRA standard was not evolving at the same pace. So new standards emerged, ADAS C++ 14 being the primary one for the C++ development. So what we do at Parasoft is we actually provide technology which helps you at each stage of the software development process to build safety and security into the application. One of the things to remember is that if your application is unreliable, it is secure by definition. Unreliability within a system is the exploit that somebody will take to compromise your system, compromise the data, or compromise the integrity of its operation. Now, there are a couple of different strategies that you can take when it comes to identity and security issues within an application. One is that of prevention, meaning that I'm trying to stop the problems from being injected into the process or into the code base in the first place. Or detection, where I'm in essence going on a bug finding exercise, trying to find the issues as they exist. Now, you want to use both in conjunction with each other, but prevention is really the key to ensuring that you're building reliability and security into your application from the start. So you want to blend these two techniques together, and certainly with the Parasoft static analysis engines for C, C++, Java, and .NET code, we're able to bring all of that together. Now, it's important, though, that it's not just about creating reports and creating the dashboards that Jason just mentioned a few moments ago. Those are critical to be able to understand what's going on. But for you to successfully adopt these types of quality practices, what you need to do is you actually need to embed a team-centric workflow into your development process. So this is where it starts with the person responsible for the overall standards compliance within the organization, the architect or lead in many cases, defining the set of checkers and configurations for those checkers to validate against the appropriate standard, measure, orders are, CWE, CERT, for example. Those test configurations or those tool configurations that control what checkers are enabled, how they're parameterized, how they're configured, how they map to the specific standards, those test configurations or those tool configurations are then shared across the development team. Now, you're going to be leveraging this technology in a couple of different ways. Apologize, my son is coming in right through my window here, so I'm going to move. There we go. That's actually shared with the developers across their desktops directly in their IDE. This gives you the ability to analyze the code before you check it into source control. This is one of the key metrics, or one of the key mechanisms, should I say, for ensuring that you're building quality into the application rather than just trying to find the problems once they already exist. Building in behaviors that can kind of instill best practices, instill coding patterns that are in compliance with the standards. Obviously, once you've created the code, you've then checked with the static analysis prior to check-in, you check it into source control, and then your CI/CD pipeline kicks in. This is your safety net. This is where we're doing post-commit check of the code base. We are, in essence, double-checking the work from the individual developers, making sure that somebody didn't miss something. You don't want to gate the check-in. You don't want to say, hey, you can't check in the code unless it's clean. Developers are smart, timelines are short. You're going to find that to bypass that process, get code into the source control system, and then you don't have the check in place if it's all up front. What you want to do is you want to have a pre-commit model that promotes check before check-in, and then have a post-commit model where we're running this safety net of running the full set of analysis, but also doing it deeper. When I'm a developer and I make some changes on my piece of code, the impact of that changes goes beyond the scope of the files that I'm editing. When you start looking at kind of some of these deep reliability and security issues, they cross boundaries of files, of classes, of modules. And this is where the deep code analysis being run as part of your CI/CD process can really help uncover those problems. Then as we move forward from that, the results from that process can then be used for the dashboarding and reporting that Jason was referring to earlier, giving you a very quick view of what's going on within the quality of the code base as it relates to the compliance of that standard, but also data from across different projects, from across different parts of the code base into a centralized reporting location, which can be used for compliance reporting as well as monitoring processes and quality practices. However, obviously, this data ultimately needs to get back to a developer, and that's where the communication goes round trip. So here, what the developer can then do is directly from within their IDE, be it an Eclipse, Visual Studio Code, can directly download the results of that automated run through the centralized reporting and analytics dashboard, and put that data directly into the IDE where they can do their remediation. The dashboard gives you the ability to be able to navigate the data, understand the details of the code base. So it's not just a simple graph and chart. It gives you that deep data. And then what you can do is you can leverage metadata to annotate and assign and prioritize the particular static analysis violations that need to be remediated. But static analysis is really only the first part of building code that is safe, reliable, and compliant with ISO 26262. We obviously need to test and validate that it meets our defined requirements, and automate acceptance testing where appropriate. So typically what you're going to see is you're going to see a whole bunch of different work items being generated in systems such as Codebeamer, Siemens, Polarium product. Also Jira as well is also very popular within our client base. And what you're going to see is those work items or requirements need to have appropriate tests which are validating that they are functionally correct. And these are kind of moving up the higher levels of the V model from a development perspective. So you're going to start at the lowest level with unit tests, validating that the code is well structured and that it complies to the low-level module requirements. And then as we move up our technology stack, or if you're following the V model, the right side of the V, we're going to start looking at integration tests. API testing is a great way to be able to validate those functional modules at the integration level. Typically, we're looking at APIs which are RESTful APIs, especially when you've got kind of a cloud-based platform, such as Renovo's microservices platform, and being able to test and validate each of those components individually, but also as they work together. And then as we move further up the stack, and started validating things at the UI level. At Parasoft, we have clients both within the safety critical space as well as within traditional enterprise IT. And this is within traditional enterprise IT is heavily focused around web UIs and the UI ecosystem that sits on top of those RESTful services. And Selenium is the platform of choice there when we're talking about those type of test automation frameworks. But if we talk about specifically the types of framework that are leveraged within very heavily within safety critical industries, and especially on target or embedded based development, this is where we can leverage integration and unit tests to validate the different modules and architectural requirements of our system. Now, what you want to be able to do is be able to run those tests both on the host and on the target, meaning I want to be able to do it on my development machine, but also I'm going to want to be able to run those tests ultimately on the embedded device when I'm doing maybe a sensor for a braking system or a steering system or something like that. This is one of the things that Parasoft C++ test fully supports, and it gives us the ability to be able to do target testing on the host, typically static analysis and host-based unit testing. But then through the use of the integrations with the compilers and the vendors that we partner with there, able to test on the target and on the boards as well to give you true fidelity testing within your environment. The test cases are created in source code as well, so they're actually running as close as is practically possible to really emulate what the behavior of your code will run like on the actual target. Now, unit testing is called out by ISO 26262 as a requirement. It talks about better code design as being one of those outcomes, but it also does reference boundary values, fault injection as being some of the things that you need to be able to validate for the robustness of your individual units. This is where with C++ test, we can not only create and guide you through the creation of the source code-based unit tests, but we can also automatically generate unit tests for robustness testing and error guessing, meaning that we're actually applying heuristics against the code, and we're using those heuristics to expose underlying issues within the code base. Ultimately, unit tests, anything that's lower on the V or lower on the technology stack, is easier to diagnose, is actually also easier to automate as well and plug into your CI/CD pipeline. But you still have higher level system interfaces, and this is becoming more and more prevalent within the automotive space as connected cars are the norm now. Systems such as Renovo is working on the edge and communicating back into the cloud. Connectivity has never been more important. What we need to be able to do there is we need to be able to do a couple of things. First of all, we need to be able to validate the connectivity of the device, but we also need to be able to create a test environment that is that we can manage and we can modify to create full test coverage or full functional test coverage. This means we need something that we can use to simulate the external dependencies. And this is where we're going to leverage a concept from our enterprise IT brethren. And this is where we can use something called service virtualization. Service virtualization gives me the ability to be able to emulate the back-end system requirements and see the different behavior in different scenarios, different performance characteristics, which allows me to really do shift-left performance testing and penetration testing. It gives me the ability to run different scenarios, so I can actually run different boundary tests. I can put my system into a state that otherwise in a production environment would be much harder to achieve. So service virtualization is a relatively new concept within the automotive space, but one that has been very well leveraged within financial services markets, specifically around performance testing, and kind of through those worlds where you don't have access to your full test environment. So we've now got an automated set of tests. We've got the unit tests. We've got some level of integration tests and functional testing in place. But there's another to do, and that's to capture the code coverage and understand what parts of the code base were being exercised during those different testing activities. And ISO 26262 calls out two different types of structural code coverage. It talks about code coverage for the software unit at the lowest level of the code base. So we're going to talk about here your unit tests, or maybe going into your integration tests as well. Types of coverage that you're going to be looking for there: statement, branch, MCDC, which is the most intensive type of coverage and really reserved for the ASIL-D systems. And this is something that you're going to want to be able to dig into details around the different branches that are being exercised through your application. As you move higher up the V, though, get granular coverage data is actually very expensive, and it becomes harder and harder to be able to understand the impact of that coverage or the impact of specific tests and specific test runs on those underlying coverage levels. This is where the coverage level of function or core is at a higher level within the code base, but it's used to more validate at the architectural level or at the system level. Now, what you want to be able to do, though, is you want to be able to aggregate the data from across different testing practices. So you want to be able to aggregate your unit testing, your integration testing, your system testing, and aggregate that coverage information into a centralized aggregate view, so you can get a true view of the completeness of your code coverage and your testing practice. This is something that the Parasoft reporting and analytics dashboard that we mentioned earlier really gives us the ability to do. And what the Parasoft reporting and analytics dashboard does is it actually aggregates data from across all of these different testing practices, from the code analysis with AutoZar or Misra, through unit testing, API testing, functional validation, and the code coverage metrics, aggregates that together into one centrally managed reporting and analytics dashboard that gives you this centralized view of quality that you can use to audit your process, and that you can use to really get visibility as to how well you're doing from the point of view of where you are on your road to compliance with ISO 26262, but also generating the documentation that you need to be able to demonstrate compliance to an auditor. However, it's not just about getting the data. The data needs to map back to the left side of your V. It needs to map back to the original requirements in your original system of record. And this is what the reporting and analytics dashboard also does. So here we're able to send the data back into the original system of record, Codebeamer, for example, and set the status of the different work items, the different requirements, and be able to control that status based upon the testing results that have been aggregated within the Parasoft ecosystem. This means you can use Codebeamer, Polarian, for your requirement traceability matrix. You can use that as a single pane of glass to manage your work items and be able to manage the visibility or get visibility as to how those work items are progressing. But it also means that we're able to aggregate not just those work items with test results, but also aggregate that with all of the other quality data that we're aggregating within the Parasoft ecosystem, which includes code analysis data. So as you tell Parasoft about the static analysis results, as you tell Parasoft about the compliance with the different standards, we can also take information about what particular files or methods are associated with specific requirements in the external system, and give you a view as to how risky different classes or different files within your code base are, based upon not only the testing data, the coverage data, but also the static analysis data as well. Then lastly, as you're reviewing the results within the quality dashboard, you're going to find things that are failing. You're going to find static analysis violations that need to be addressed. You're going to find tests that are failing as part of your automation sequence. When you're triaging those, you're going to want to be able to tag specific tests or test failures or static analysis violations and create additional work items in the system of record. You can do that through the rich explorers within Parasoft's dashboard, which give me the ability to be able to navigate the data. Now, as mentioned this earlier with the workflow, where as we send the data into the dashboard, we have all of the details behind it. It's not just a graph or a chart. We have the detailed information about the source code, about the stack traces, and we're able to navigate that information. And then once you've determined that there's an issue within the code base, you can use the integration with your work item management system to create new defects or issues that need to be remediated within the code base. So hopefully that kind of helped and kind of we showed how you can go from the static analysis and validating the quality of the underlying code base all the way through different levels of functional verification and tying that together back with the original system of record. Parasoft has a very broad suite of products and technology. The one which we're talking about today predominantly is Parasoft C++ test. Key elements around that, as I mentioned, are the security standards, unit testing, code coverage, both on target, on host, as well as for unit testing, as well as application monitoring, and bidirectional traceability, so being able to go from requirement to code to test and back again. And then last but not least, the technology that you need to be able to validate ISO 26262 compliance needs to be certified itself for use within the industry. So C++ test is TÜV certified for ISO 26262, and there is also a qualification kit available for ASIL-D if you require tool qualification processes for ASIL-D as part of your internal process. For those who are trying to frantically type in that URL, we've actually injected a live link here. So if you're interested in clicking on this link, what you'll see is you'll be able to see the C++ test product page. So I'll just keep that for a second. And then once you've clicked on that link, you'll see the page itself, and you'll see a button here in the middle which says try Parasoft C++ test. If you click on that, one of the Parasoft team will be able to get back in touch with, give you a demonstration of how this all works, talk about what your specific requirements are, and kind of get you going with the trial so we can kind of show you how it would work within your environment and help you to achieve compliance. Another quick link for you to follow up and learn some more is our blog. If you click on this link, you'll see that there's a whole raft of different articles talking about different things within test automation. Some of the profiled ones today are around CMake and Docker. We just did a new release of C++ test. So you'll see some blog on the new release. You'll see, as I said, some blogs around Docker and CMake integrations. So you'll see one coming up next week around Visual Studio Code. And we're actually running a webinar on our integration with Visual Studio Code. So with that being said, Jason, I'll hand back to you for any closing comments or where people should go for information about Renovo.
Yeah, thanks, Mark. Again, our sincere thanks to the Automotive IQ folks for facilitating this, and for our partners in Parasoft for inviting us today. I've had a really good time. I think we're going to answer some questions here soon. But as I mentioned, we build an edge-centric automotive data management platform. We work with a lot of OEMs and Tier 1s. If you're interested in more information, you can go to our website, www.renovo.auto. If you'd like to ask some specific questions, you can send an email to info@renovo.auto. And that's about it. I think we're ready for some questions.
Cool, guys. Thank you very much for that very in-depth presentation. I feel like I'm vastly more knowledgeable about everything you guys offer now. Let's jump straight into the Q&A. So our first question is, Is the privacy aspect considered when extracting data from the vehicle? Could you please elaborate a little on this topic?
Yeah, so I assume that's for me. The privacy is vitally important. I think I mentioned briefly the GDPR requirements that Europe's implemented. We see that as vitally important. One of the things that I think is powerful about the way that we do our data management is it's as I mentioned, it's at the atomic level, it's at the channel level. So a lot of data management systems that are out there today are more file management systems. They're managing the data in bulk, a giant ROS bag or a giant blob without really understanding the data that's inside. One of the keys of being able to break that up into individual pieces is you can actually apply different workloads to it to obfuscate the identity of where it's coming from. Also, part of our system was intentionally done as one of the benefits of doing it as a microservices system is you can actually insert workloads into the data flow at any stage, whether it's right at the output of the creation phase where you're obscuring, let's say, license plates or faces before it gets stored in the local database, or you can store it in a local database in raw format, but before it gets transported off the vehicle, you're doing that obfuscation. So it creates a flexible environment where you can basically address the privacy issues. We think a lot of our, not just we think, a lot of our customers, that's really important to them. And they are doing exactly that they're inserting services in between the data flow to at the appropriate stages to ensure privacy.
Okay, cool. Next up, we have, if all computations happen in the vehicle, it will no doubt be faster and save decision time as compared to computing via the cloud or 5G. Is the industry moving more and more towards cloud computation?
It's a mix. So the vehicle is a great place to do that computation from the perspective of it's local. You can do data reduction. You can make a lot of decisions at that level. The challenge is your most expensive compute and your most expensive storage are at the vehicle side because it has to be hardened for automotive standards. But of course, we're now seeing also lots of cost of pushing so much data up to the cloud, and just the pipes aren't large enough, even with 5G. And so it ends up being a mix. I think Tesla has a really powerful model today where they're taking the compute that they're using while the vehicles are driving, and in the evenings when they have downtime or when they're charging, they're repurposing that compute to do a lot of edge-based computing. That is something that we see is really powerful. We didn't talk a lot about our application and workload management layer, but we have a whole layer that sits alongside our data management layer that actually can manage those workloads and deploy them and trigger them and start them at the appropriate times. But yeah, that we see as there's going to be a lot more computation done at the vehicle level, higher level computation, in addition to the cloud.
Cool. I guess, Mark, this one might be more for you. You mentioned that their clients are using Jira. Can you use that for compliance?
Yes and no. Typically what we see, especially within safety critical, is organizations that are using Jira are using that to do the kind of the task management or the sprint to sprint management of the development team. So it's normally tasks, defects, and issues. And then that's supplemented with a system like a Codebeamer, for example, that's doing your true requirements traceability. So those are kind of typically the environments where we see kind of the blended model. Jira is very valuable and popular for individual development teams and for their management, but it doesn't have the rigor from a requirements management perspective that you really need. Now, there are a lot of plugins for Jira as well. In fact, actually, Jira doesn't have native test management built within it. So there are plugins like X-Ray, Zephyr, Q-Test are kind of the three most popular ones. But as I said, Jira is normally at that lower level and is normally something like a Codebeamer or a Polarian that's used for your requirements traceability.
Okay, cool. This one's another one for Jason. Can you share a little more of the detail of Renovo's business model of its software as a service for OEMs or even for a solution integration partner in the automotive industry?
Sure. So we work with, as I mentioned, we work with global OEMs, systems integrators, tier ones, lots of different people within the industry. We have a lot of flexible options based on their individual needs. So whether that's a license model and how that licensing works or how they, basically want to structure it. So there's no one simple answer to that question. If you're interested, please reach out to us at info@renovo.auto, and we'd be happy to talk in more detail and understand your requirements and figure out how to work with you.
Cool. And hey, Mark, how about which standard do you think is better, AUTOSAR or MISRA?
Depends what you're doing. So I kind of mentioned a little bit to this earlier. So MISRA C 2012 is the standard of choice for C development, which has been historically very strong within the embedded community, and especially obviously within automotive. However, as I mentioned, MISRA hadn't really evolved their C++ standard since the C++ 2008 standard was released. So this is where AUTOSAR is the clear choice when it comes to C++ development, which is obviously what our friends at Renovo are using. Interestingly, the AUTOSAR and MISRA bodies, if you like, have come together and kind of announced that they're going to be merging the two standards. So we expect to see a new MISRA C++ standard in the near future. These creations of new standards always takes a lot of time, and they've actually said it's not going to be simply just a rebranding of AUTOSAR C++ 14. They're actually going to be taking that into consideration, but also expanding its scope, which probably means it'll go through a number of phases. So I would expect to see some kind of draft probably around about the Embedded World Conference next year, is my just personal opinion. But certainly if I'm doing development today, if I'm doing C development, I'm going to be using MISRA, MISRA C 2012, I'm doing C++ and C++ 14. Obviously, as I showed today, we support both, and both we have the compliance reporting, applying the MISRA, actually MISRA 2020 compliance standards to the compliance reporting framework to those, to both of those standards.
Cool. Let's have a look more. Another question. I guess this is a question also a bit amusing. Does it mean that incident investigation for transport accidents should be able to be more in-depth, sooner and better and reliable, and also for criminal activity, breaches, and hopefully sources too?
Yeah. So yeah, I think it's talking to. We had talked about the liability aspect of how data is going to change that. Yeah, we definitely think all of these are true. That incident investigation will definitely be. This is well put. Basically, more in depth, better, and sooner and more reliable. There was a tragic event a couple years ago in the autonomous vehicle space where a pedestrian was killed. There was a lot of lessons learned by the industry around that. One of the things that I think was really interesting and was lost largely in the press and also largely lost by the industry was the level of detail that was able to be extracted from that incident. If that incident happened at night on a dark road, if that had not been an autonomous vehicle with the amount of data that was being collected, we ultimately would have no idea exactly what happened. But in this case, we had camera data, we had LiDAR data, we had the vehicle system data down to the millisecond level, and we were able to reconstruct, the investigators were able to reconstruct that entire scenario and understand exactly what happened at every moment in time. We think that's a that's a game changer in terms of how these things are investigated and how we're able to understand aberrant behavior.
Cool. That's a really good insight. I think we have just going to squeeze one more in. I think this one's maybe more for Mark. How does Docker affect the deployment of static analysis?
Okay. So really, Docker being containerization platform, it really doesn't affect it so much from the point of view of, you have to do something different. Basically, what you're going to be doing is you're going to be wrapping your static analysis toolchain into your Docker container that you're leveraging as your CI/CD pipeline. Docker, we're seeing increasingly being leveraged within the embedded technology space, especially as organizations are trying to ramp up their software development teams and are looking for ways to be able to more easily standardize and pre-package their embedded tool chains together. So Docker is actually something that we've been supporting for a number of years through our enterprise clients. But as I said, now we're beginning to see it more and more within the embedded tool chains as well. So how it affects your deployment of static analysis per se, it just means that the static analysis tool gets embedded into your Docker container, and then it's deployed through your Kubernetes managed infrastructure. We actually, I mentioned earlier, the recent C++ test release, and then we had some blogs on the website talking about CMake. I mentioned that VS Code was coming, and Docker is actually on there as well. We did a webinar a couple of weeks ago about that too. So definitely invite you to check that out more. If you've got more questions around how to leverage Docker in that ecosystem as well, just reach out to the team and we'll be able to kind of follow up with you on that.
Cool. Thank you very much. That's probably all we have time for questions. Thank you very much again to Mark and Jason for the presentation and for giving up your time to do the Q&A too. If you'd like to listen again, the webinar will be available on demand from tomorrow. There's also a selection of resources on the right-hand side of your screen in the resource list. There's some white papers and links to other Renovo and Parasoft bits and pieces in there. They're all well worth a read. Just before we head to the next session, the pop-up link will come up again, so you can link to the next one straight away. And make sure you check out our online event. Bottom left-hand side, there's a box to click for automotive safety and security online for more presentations along similar themes to this. Thank you very much for watching, and I hope you can join us again for the next session of Autonomous Vehicles Online, which will begin in about 8 minutes. So we will see you then.